Alright, I'm going to skip the usual preamble and let's get straight to the concept that makes multi-chain data actually work. It's called as like content addressing. Once you understand it, everything else would click into place. When you store data on Filecoin, you don't get back a URL or file path. Instead, you get something that is called as a PCID, which is a cryptographic identifier computed directly from the bytes you have uploaded. The data itself generates the identifier. So, if you change even a single bit, the entire PCID would be changed. Now think of like what does that mean for a multi-chain application? The PCID isn't tied to any like particular chain. Like it's not tied to Ethereum or Base or any particular blockchain. Like it's a mathematical derivation of the content, which means a smart contract on Ethereum and maybe like there can be another one on like Arbitrum and maybe another on any other chain that doesn't even exist can still call the reference of the data using the same PCID and retrieve the same verified data. You don't need to share a backend or a centralized API that you're hoping it stays online forever. The identifier works everywhere precisely because like it isn't like anchored to anywhere. So to see like how this plays out in practice, consider an NFT. Okay, an NFT collection that you have to launch across multiple chains. The artwork and metadata are identical, but you want the collectors on Base, Ethereum, and Arbitrum to mint directly from your preferred network. The traditional approach would involve spinning up a server to host the images and hoping that it stays online forever. When the server eventually goes down, thousands of the NFTs, which are part of the collection, would suddenly point to nothing. If you have spent like time around like browsing around like OpenSea, you would have seen those broken image placeholders, and that's exactly what happens when centralized storage fails. With Filecoin Onchain Cloud, you can upload your asset once and retrieve them with a PCID in return. You embed that PCID into every chain's NFT contract and you are done. When a wallet or marketplace needs to display the NFT, it requests the data from that PCID. The Synapse SDK locates a storage provider, retrieves the content, and then automatically verify what came back by computing the cryptographic hash. If anyone tried to, serve or corrupt or like tampered data, if they are trying to serve like these tampered data, the verification would fail because the math simply wouldn't match, right? Trust isn't like required when the verification is built into the identifier itself, and that's how like the entire concept of CID works. The NFT on Ethereum displays the same verified image as on the NFT on Base, with no server sitting in between that. And since no server is sitting between that, nothing good is going to break. Now this pattern extends well beyond like NFT images. NFTs were just for an example. Okay, think about a social protocol operating across multiple chains, or a DAO governance tool, or maybe a game where player assets exist on like several servers or several networks simultaneously. User profiles, posts, votes, and inventory all need to be remaining they need to remain consistent regardless of which chain they come from or which chain are those linked with. You store that data on Filecoin, where the storage providers must prove that like they still hold the data every hour, right? Very frequently they need to prove that they are holding the data, and this is the mechanism which we call as like proof of data possession. They can't simply claim that, hey, like I have stored your data successfully. They have to cryptographically demonstrate it on an ongoing basis. Your application would read and write to the Synapse SDK, and every chain would reference the same PCID with confidence that the underlying data is both verifiable and persistent. Now, when like retrieval speed becomes important, there's a CDN layer called as Filecoin Beam that cache all the frequently accessed content at edge nodes around the world. So you can enable it with a single flag in the SDK configuration and retrieve the data even much faster while the guarantee of the verification would still be there. So, cross-chain synchronization like emerges naturally from this same architecture. When your application is on like one chain and writes a new data, it receives a PCID, and that can be like emitted as an event. It can be passed through a cross-chain messaging protocol, for example, like XLR, and stored in a shared registry contract. Your application instance might be on some another chain, but it can still pick up that reference and immediately retrieve the same verified content. That data itself doesn't care like which chain is it requested from. For teams like who are building at the protocol level, there's also the infrastructure for triggering storage directly from EVM chains through the on-ramp contracts which we have, and they can like handle the entire Filecoin interaction without users ever leaving their home network. So that's pretty cool for like the folks who are building the application at like protocol level. So XLR is there to manage all the cross-chain proof delivery, and like so that's like worth exploring if you're building foundational tooling, and for like but most of the applications the SDK abstraction would cover almost everything that you ever need. So the Synapse SDK itself is a JavaScript based. So you can initialize it with the RPC endpoint. Then you can deposit USDFC or fill to cover the storage cost, and then call the main upload function. The SDK would handle provider selection, proof management, payment flow automatically, and it would just return you with a unique PCID that you can use immediately across any chain. So the retrieval would work in the same way. You can download the data with PCID and receive like verified bytes in return to verify whether the data is perfect or not. The SDK would perform all the cryptographic verification behind the scenes, so you are never trusting any providers blindly. You are verifying everything they need. So now the bigger picture. A data layer that doesn't belong to a single chain, where you and where your entire like multi-chain stack can share storage instead of like each deployment solving the problem independently. NFT metadata can genuinely cannot like disappear now. Backends state that can remain like chain agnostic from like day one. So that's I'm sure like the developers who are watching this would really love this news. So the synchronization that works through mathematics is like provided with like FOC instead of like your servers that you'd have to maintain and constantly put a check on that. That's pretty simple, right?